Okay, thank you. Welcome to all of you. Can you hear me well?
Yes, of course.
Okay, so I share my presentation. Okay. Is it already visible?
Yes, we can see your presentation.
Thank you. My name is Adrianna Wojtal-Frankiewicz. My lecture focuses on the use of zooplankton for water quality assessment. The species structure of zooplankton, as well as the biomass and density dynamics, provide information about the relative importance of top-down and bottom-up controls and the impacts on water quality. This is because the zooplankton community structure is determined primarily by the physical and chemical environment and is modified by biological interactions. Particularly useful and important indicators of bottom-up processes are rotifers, because they are only slightly affected by fish predation and the abundance is largely okay.
Professor, now we can see your full screen, okay? Because firstly we haven't seen it, and we also have the first slide. So if you could change.
So I tried the share presentation again. Sorry.
Yeah. Okay.
Maybe it is small. Okay, sorry. And now?
Yes, now we can see your full screen.
And
it
is moving?
Yes, yes, it is.
Okay, okay. Sorry for this problem. So, as I said, particularly useful and important indicator are rotifers because they are slightly affected by fish predation, and the abundance is largely related with food type and food quantity, which in turn results from the changing nutrient levels along the trophic gradient. The sensitivity of rotifers to changes in the trophic states of lakes has been well documented by many researchers. However, only few zooplankton indices have been developed to date. The comprehensive analysis is also missing, which is unnecessary for zooplankton to be included in the Water Framework Directive as one of the biological elements allowing to the determination of water quality. Today, I will present two indexes applied in Poland. The first, the rotifer trophic state index, was developed and tested in 74 Polish lakes of different trophy to assess the practical application of rotifers as potential indicators of the trophic state of a lake. It is worth mentioning that during the development of this index, data on rotifers density and taxonomy were used to assess the relationship between rotifer community structure and indicators of lake trophic status calculated according to the well known, the Carson index. On the basis of observation and research, a series of mathematical equations have been developed to describe the relationship between rotifer population dynamics and ecosystems trophy. All regression equations were converted into formulas which enable to calculate the trophic state index from the parameters characterizing rotifer communities. The long-term studies confirmed that the formulas can be used to help researchers assess the trophic status of any lakes, both deep stratified lakes and shallow polymictic lakes, in Central and Northern Europe using the rotifer data. This index may also be useful in preparing similar indices for lakes in other parts of the world, but may need to be modified for differences in the taxonomic structure of rotifer communities. The analogs index is the crustacean index. It was also developed and tested in 74 Polish lakes of different trophy. In general, the crustaceans appears to be poorer indicators of lakes trophy than rotifers. However, there are some patterns of crustacean communities related to the trophic state of lakes. Thus, an increase in trophic state causes specific changes in the structure of crustacean communities. For example, the increase in the total number of crustaceans, increase of the share of biomass of Cyclopoida, increase in the contribution of biomass of Cyclopoida to the total crustacean biomass, or increase the ratio of the biomass of Cyclopoida to the biomass of Cladocera, decrease in the average body weight of Crustacea, and others. And there are the mathematical equations used in the crustacean index, and you can see that they are very they were prepared in the analogs way, like in the case of the rotifer trophic state index. The trophic state indicator values for zooplankton are as follow, and you can also see that a value below 35 in this is oligotrophy, and the higher value of points are connected with the higher trophic state of a given lake. Zooplankton base indices, and in particular the rotifer trophic state index, perform well in water quality studies of urban ecosystems. We tested it as a part of a study on the effectiveness of nature-based solutions in the Arturówek recreation complex in the city of Łódź. The main objective was to evaluate the usefulness of zooplankton as a biological quality element when assessing the effectiveness of restoration efforts in 3 urban reservoirs. We assumed that the changes in the abundance and species composition of the main zooplankton groups will reflect changes in the amount of nutrients and water quality resulting from restoration efforts. We conducted research in 3 main reservoirs: Arturówek, upper, middle, and lower. Each of them is used in a different way, which affects the water quality in these ecosystems. Before reclamation, the rotifer communities in the Arturówek reservoirs were dominated by taxa that are typical for high trophic conditions. During this period, other symptoms of eutrophic conditions associated with zooplankton were also observed, such as occurrence of Cladoceran species characteristic of eutrophic waters, for example, Bosmina longilostris, Diaphanosoma branchirum, or Hydorus sphericus. Also, the high abundance on Cyclopoida and the naupli, and the high ratio of cyclopoid biomass to Cladocera biomass was observed. This ratio is related to the trophic status of the water, and its high value is characteristic of eutrophic conditions. This is because eutrophic lakes provide favorable food conditions for many omnivorous Cyclopoida species, including the availability of detritus and bacteria for the juvenile forms. After reclamation, we observe contribution of species that are indicative of high trophic conditions decrease. Also, the ratio of cyclopoid copepod biomass to the biomass of Cladocera decrease. We observe significant reduction in phytoplankton abundance and reduction in rotifer biomass, and average weight also was observed. You can see the results of the rotifer index in Arturówek reservoirs on this figure. Here is the marked by yellow is Arturówek upper, by blue is lower Arturówek, and middle Arturówek is marked by red. Only in two cases the index values are at mesotrophic level, but in one case at eutrophic level. Only in upper Arturówek, the percentage share of bacterivorous of rotifer index values did not change despite the removal of sediments and decrease in the concentration of chlorophyll A. However, the upper Arturówek was the only point of all of the study points that is adjacent to the short stretch of river, but not another pond. So we assume that the rotifer communities were mainly derived from the river. In summary, our results showed that the rotifer index was strongly positively correlated with the trophic state index based on chlorophyll A, and both parameters significantly decreased in two reservoirs. Our research confirmed also the high potential of biological indicators in assessing the ecological quality of water in small urban aquatic ecosystems. However, comprehensive assessment of restoration efforts should be based on the also monitoring of both biological and physiochemical components in terms of the use of the ecosystem and the nature of the catchment of this ecosystem. Urban reservoirs are more exposed to anthropogenic pressure than natural lakes, and therefore monitoring with the use of bioindicators sensitive to the deteriorated trophic status, such as rotifers, should be particularly recommended here. Currently, 10 years after the rehabilitation of Arturówek reservoirs, we continue the studies using zooplankton indices. And the practical use of trophic zooplankton indexes, especially rotifer index, you can find in our papers. Thank you for your attention.